Hi friends, welcome to my channel JK Competitions. This is your Ajay Minar. Today we are going to discuss a few numericals from a chapter called Light. Light chapter we are going to discuss few numericals, and these numericals are benefited for two reasons. One is this class is very benefited for those students, those who are going to appear for board exam board exams February 2026. And second one is, which is very useful for the one applicants who are applied for EMRS, in that PGT physics and SGT TGT candidate also can be benefited out of this one. So this class is very useful for these two kinds of people. One is students, that means grade 10 students, those who are going to take the board exams. Second thing is those who applied for EMRS, PGT or TGT, whoever is there, PGT or TGT applicants is very important. You know why? Here EMRS, anyway, board class students, they have to take um, descriptive question and answers. Similarly, EMRS also we have two patterns. Tier 1 we have tier 1, and tier 2 also we have. In this tier 2, tier 1 and tier 2, and tier 1 which is tier 1 which is completely MCQ for 100 marks, but in tier 2 which has MCQ as well as description, both are there. MCQ are for 40 marks and a description are for 60 marks. In 60 marks, 15 questions are there. Each question carries 4 marks, right? So 60 questions description part is there. That's why this class is very useful for EMRS 2025 applicants also. So without wasting our time, we'll start today's class. Here is you have a numerical, right? Very important numerical. This is repeated many times in board exam, but same question may not be appeared. But the model can be appeared here, right? First of all, let's see a question here. Question: an object is placed at a distance of object is placed at a distance of 60 centimeter from a concave lens. There is a concave lens, right? Object distance is given. Now whose focal length is 30 centimeter. Focal length is given as 30 centimeter. Now use the lens formula to find the position of image formed in this case. Position of image means image distance we have to calculate. Okay, object distance is given, focal length is given, image distance we have to calculate. Now let's write for description purpose I'm telling. And what is given here, the given is object distance u is given here. That is, object distance is always negative, that is 60 centimeter, right? Next, focal length is given here. Focal length f is given here. Focal length is, it's minus 30 centimeter. Focal length is minus 30 centimeter. Now next one, what is required here? We need image distance. V is required, that we have to calculate. Image distance we have to calculate here. Now it is a concave lens. Which lens is given? Concave lens. For concave lens, object distance is negative, as well as focal length also negative. concave lens. For concave lens, even image distance also should be a negative for concave lens, right? So we got data here. Object distance is given. Object distance 60 centimeter, focal length 30 centimeter is given. Now image distance we have to calculate. Now we have to use a lens formula here. We know lens formula for lens 1 by f is equal to 1 by v minus 1 by u. In textbook it is given like this. In textbook 1 by v minus 1 by u is equal to 1 by f. Anything you can use. That's up to you. Anything you use, there will be no difference at all. Now let us use this formula by using, or let us apply all the values here in this formula, lens formula. You can use any formula here, right? No difference here. Focal length is given negative 30 centimeter. Then 1 by v that we have to calculate. Now 1 by object distance is given minus 60 centimeter. Minus 60 centimeter here should be given here. That means this is 1 by v plus 1 by 60, that equal to 1 by minus 30. Now what we need here, we need image distance. Take image distance out. 1 by v is equal to 1 by minus 30 and 1 by 60, right? 1 by 60. Now let's take the LCM for this. LCM is 60 here. Now 30 will go 2 times here, minus, and 60 will be 1 time in 60 here. Now next step here is 1 by v is equal to minus 3 by 60. Now we need v, image distance. We don't need reciprocal. We need image distance v is equal to 60 by minus 60 by 3. That gives you minus 20 centimeter, because object distance is given centimeter, focal length also given in centimeter. Now image distance also in centimeter. Image distance also is in centimeter. Minus 20. That means object, image and focal length all are negative. All are negative for concave lens here. Now the image is formed at 20 centimeter on the same side as the object. That means object and image both are on the same side. Then that image is formed 20 centimeter away from the center of the lens. Now the nature of the image, it is virtual, erect and diminished. Nature is virtual, erect and diminished. A diminished image will be formed. Virtual, erect and a diminished image is formed. So this is the answer for this question. So we got object distance, we got focal length, and we finally find out the image distance is there, that is minus 20 centimeter. From that we can understand that image is 20 centimeters away from the center of the lens. Nature of the image is virtual, erect and diminished, right?